There will sadly be no intro for today's class. Today we're going to continue looking at inequalities. We're going to look at taking a inequality of functions written as an inequality and graphing them. And then also starting with the graph and going to what is that inequality? What's the rule that describes the inequality when it's graphed? So to do this, let's see if I can remember how to do this. Add a picture. Photos. There we go. My Cartesian plane. Yeah. So we'll add this in here. I'll make it a little smaller. So we have to start with a inequality. So you'll need a chart paper, or at least something to do a rough sketch on. Okay. It's a little difficult to see the numbers, but each box is equal to 1. Alright, so let's start with this. Graphing inequalities. So let's start with an example. I think the easiest way to look at these things is through examples. And the example I'm going to give you is this. Negative x plus 4y is less than negative 4. And there's actually a few different ways that you can go about graphing these inequalities. I'm going to give you one way, and then I will describe to you a slightly different way, and you'll see if it maybe works better for you. I think this is probably the easiest way. So I'll do the steps in red, and then I'll show you what they actually will look like in our example. So step 1. Okay, I'm going to write the inequality in y equals ax plus b form. Obviously you won't have an equal sign because we're dealing with inequalities, but it'll be in that form. Right? And that's why the question from the homework a couple days ago was just asking you to rearrange inequalities. So what will that look like for us? For our inequality, negative y plus 4, negative x plus 4y is less than negative 4. We will first have to add x to both sides. So I'll rewrite it. Negative x plus 4y is less than negative 4. I'm going to add x to both sides. So that gets rid of that. I have 4y is less than x minus 4. Divide both sides by 4. So to divide this by 4 and this by 4. I'm going to get y is less than 1/4 x minus 1. Or if you prefer, 0.25 x minus 1. Okay. Step 2 is to draw the line that represents your inequality. So, what do I mean by that? Drawing the line that represents your inequality. You're going to draw this, you're going to graph this as if it was just a line. Okay? So as if it was just a line, not an inequality. So as if this symbol here was an equal sign. Now there's a bunch of different ways that you can graph lines. and you guys may have ways that you are more comfortable with than others. Okay. One way is to just sub in some points to make a table of values to graph some points. I'm going to show you a way that works generally pretty well, and it makes your calculations easiest. So if you want to just make a table of values, let's just do that first. Okay, you could say, all right, I got a table of values. I don't want it red. I want a table of values. Finally, x's and y's, and you could say to yourself, okay, I'm gonna do some x's. I'm gonna do x equals 0. I'm gonna do x equals, I don't know, 4, and x equals 8. For this one would give me some nice numbers, and then you solve for y. So I would plug it in. I would go y equals 1/4 times 0 minus 1. And so for this one, y would equal 1/4 times 0 is 0, minus 1 is -1. And so I just figured out that for the point x equals 0, y equals -1. Okay. I could then do the same thing for my next point. Y equals 1/4. And I'd try 4 minus 1. Y equals 1/4 times 4 is +1 minus 1. Y equals 0. So my point, I have 2 points now. I have the point 0, -1. I have the point 4 and 0. If I plug in 8, I'm going to get that y equals 1. Alright, I don't have room to do the calculation, but just trust me. Okay. So I have 3 points now, and therefore I can graph those points onto my graph. So let's see. Make this a little bit bigger. Actually, I can make it quite a bit bigger because I only need part of the graph. So that should give me enough space. So I have the points x equals 0, y equals -1. X equals 0, y equals -1. That is this point right here. Actually, I'm going to do it with a different color so we can see it better. Alright, so I got a point right there. I don't know if you can see it. Point 0, -1. Right. I also have the point x equals 4, y equals 0. So that's this point right here. Right. Can I see that point? And then I also have the point x equals 8, y equals 1. So point 8, 1. That's this point right here. So you can see I've got myself 3 points. They seem to be making a straight line. That's good news. Okay. There's one little piece here that we haven't talked about though. Okay. That one little piece is that even though we're drawing a graph here, and we're drawing a line, sometimes your line will be solid, and sometimes your line will be dotted. Okay? So I'm going to put a little star down here underneath my notes for number 2. It's a solid line for the symbols that are this. It's a dotted line or a broken line when your symbols are this. Okay? So the difference is obviously this. Solid line if it's equal to, so if it's less than or equal to or greater than or equal to. It's a dotted line if it's less than or greater than, without the equal to. So for our example, is it going to be a solid line or is it going to be a dotted line? It's a dotted line because I have, if you look at my example, it's not equal to, it's just less than. Okay. So you're going to connect your dots same way you would if you were graphing it. But you're going to do it with a dotted line. Now, on your homework and on a test, I would expect that you're using a ruler, a dotted line that connects my points. Everybody okay so far? Your third step, if I leave it right here, that should be good. Your third step is to shade in above your line and it'll be above your line if it is this symbol or this symbol, or below your line for this symbol or this symbol. So for our example, am I going to shade above or below my line? Below. It's a less than symbol. It's saying y is less than that line. So I would shade in everything down here. Okay. All the way up to the line.
What's the point of shading?
Okay, I'll explain that in 2 seconds. Sorry, what's that, Sean?
Because it could be anywhere underneath that.
Okay. Sean's absolutely correct. Okay. We're not dealing with, when we were dealing with equalities, we graphed a line, and it was always a solid line, and any point along that line would satisfy your equality, would make that equality true. Now we're dealing with inequalities, so we have all kinds of possible answers. Okay? And for us, what we've done here is we've represented all the possible answers on a graph. So any point, if you take any point that's shaded in, any point down here, right? So I could take the point, I don't know, -3 and 9. That's this point right here. -3, 9 is that point right there. If I plug -3, 9 into my inequality, it would be true. It would work. If you look at it, -3 is my x and 9 is my y. -9, sorry. So -9 is less than 1/4 times -3 minus 1. That would give me -9 is less than 0.25. Nope, -1.25. Well, -9 is less than -1.25, so it's true. On the same note, why is it a dotted line and not solid? What do you think the dotted line means for anything that's any point that's on that line? Do you think the points on the line satisfy the inequality or do not satisfy the inequality with the dotted line?
I think they do.
You think they do? Normally you would get, if you were going to just guess, you would guess they do. Because equalities, the line satisfies the equality. But the reason why we distinguish between solid or dotted is because dotted line, they do not. Alright? If it's a solid line, if it's got the equal to symbol, right? If this is less than or equal to, it would have been a solid line, and anything on that line would also satisfy it. So what that line represents is kind of the division between points that work and points that don't work. And the ones that are right on the line would be good if it's equal to, but it's no good if it's not equal to. Alright, because I have just less than and not less than or equal to, it's a dotted line. Anything on that line doesn't work. And we can see that. We'll look at why that is. Just gonna move this up just a little bit more. Alright. And let's pick one of the points that we used. Because these points here, these are all right on that line, right? They're on that dotted line. Okay, so let's try one of those. So we'll try 4, 0 in our inequality. So we have y is less than 1/4 x minus 1. So y, oh sorry, don't want to put y there. Y in this case is 0 is less than 1/4 times 4 minus 1. Just go here. 0 is less than 1/4 times 4 is just 1 minus 1. So I would get 0 is less than 0. Is 0 less than 0? No! No, this doesn't work. Does not work. Okay? What we would see is if I put the equal to here, right? If there was an equal to and I had a solid line, I'm just going to change it that way with the red so that we don't get confused. Well, 0 is less than or equal to 0, right? It's equal to. And we would have had a solid line, so anything along that line would satisfy the inequality. But because we didn't have that equal to sign, right? Because this is not actually there, it doesn't work if it's on the line. And that's why we represent that with a dotted line. Okay. The question of where do I shade and whether I shade above or below, as long as you go through the steps of turning it into y equals ax plus b, or y is less than or equal to, or y is greater than or equal to ax plus b, these rules always apply. So that needs to be your first step. Once you've graphed it, then you can go from there. Yes?
When you shade it, you shade in both sides, or just the one side?
What do you mean by both sides? Like left and right?
Yeah.
Yes, anywhere below the line. So that's why I shaded.
Yeah. Oh, that. Oh, okay.
You got it? Okay. Yeah, so we're shading everything below the line over here on the left side of the thing as well, but nothing above the line gets shaded. Okay. Yeah, so if I was to move over so I can see my whole graph, my line would continue over here, right? And everything down here would also be shaded. And it would even keep getting shaded down this way, it would keep getting shaded down here, it would keep getting shaded here, and it would keep getting shaded over there. Anything below the line gets shaded in. Okay. Nothing up here. Nothing above the line gets touched.
Okay.
So this dotted line can continue off of my graph for all I care. Doesn't matter. It's going to keep going left and right forever and ever and ever. And the shading keeps going underneath. And that's what we're representing. Okay?